hi everyone, excited to be here. This is my first CNCF meetup. I'm Ofir, I work at Wiz, as I was introduced, and today we're going to talk about workload identities in Kubernetes. By a quick show of hands, how many people have heard about the term workload identities? And how many of you are actually using it? Okay, same people. Cool. So let's go real quick. We're going to introduce workload identities, but before that, we have to appreciate the problem at hand and what led to workload identities. We're going to show a quick demo of how can I access from Kubernetes cluster to my cloud resources like RDS, S3, etc., etc. And finally, we're going to leave you with some infrastructure as code like Pulumi, Terraform, and manual steps that you can apply to your existing clusters. Cool. So real quick about myself. My main background is software engineering. I've been doing it for quite some time. Been doing cloud native for the past 3 years, and I'm super passionate about Kubernetes security. Cool. So when we think about Docker and containers, they've changed everything, right? They changed the way we ship and package software. They changed the way we scale and orchestrate our workloads in production. But with it comes many, many security risks. You could think of vulnerabilities. You could think of misconfigurations, like you have containers running a suite in production. You could have lateral movements from Kubernetes clusters to crown jewels. You don't want that to happen in production. I mean, if you look at this list, you go to sleep with one eye open, right? I'm pretty scared when I think about security. So today, in this talk, we're going to focus on just one aspect, which is the identity and access management. The main problem that we're trying to solve, it sounds very simple on the surface, but is it? I have a Kubernetes cluster, and I want to access my database or my S3 bucket or my Google Cloud bucket. How am I supposed to do that? The first approach is obviously to put, like it's very naive, but when I just graduated from computer science and I write my first Node.js application, maybe I just want to connect to the database and see that it works. No one does that, right? I did it once, at least, and I've seen it firsthand in many companies. Wiz works with all the major enterprises in the US. So more often than not, you see this kind of stuff. And if we back it up with data, this is only from 2024. This is not from like 2 years ago, 3 years. The same SolarWinds supply chain attack that you probably have heard and familiar with, they recently had the credentials hard-coded in the web help desk product. So it's not a made up, it's something real. And I mean, there are pros for that, right? I mean, I finished my bug. My girlfriend dumped me, so I had to go home and just get some good night's sleep. So I left the credentials inside the code. Obviously, I don't want to ship something like that to production, needless to say why. Cool, so the next step in the evolution is maybe to use a secret, right? This is the best practice in Kubernetes. So we're using external secret operator in Kubernetes, and it is connected to a secret manager or vault, right? So we have our external secret, it generates a secret, and then the application uses the secret from disk and not from environment variable. So we've made a lot of progress, but there are many problems with this approach. Let's start with the pros. So we decouple the configuration from the application. Now the secrets and everything are stored elsewhere and hopefully protected by least privilege and RBAC. But think about all the moving parts. Think about the poor DevOps guy or girl that have to put everything together. I need to know how to use Vault. I need to know how to provision everything in the cloud and then link the YAML manifest. Like you need to be the YAML whisperer or something like that, right? To get everything orchestrated together. So there's a lot of pain. And also, what happens if these credentials get compromised? There is a saying that long-lived credentials are the root of all evil, and for a good reason. So if someone compromised my application, should I revoke it? Will it bring production down? There are a lot of risks around that. So the best solution that we currently have today is to use what is called workload identities. But before we introduce that and show a quick demo, let's start with some definitions. So workloads is a fancy name in the context of Kubernetes for saying apps running on pods. And then we have the human identities, which are the normal users is from the Kubernetes documentation, by the way, I didn't make it up. So these are like the DevOps or the developers accessing the cluster. And then we have the workload identities or non-human identities, which is the topic of this talk. Within workload identities, we have two entities. We have the Kubernetes service account, which is the user for the pod. And then we have the cloud IAM role. If we link the two together, we get what is called a federated identity. Cool. So I'm going to show you a quick demo. It's not a live demo because we don't have the budget. I'm sorry. So I'm using EKS Cattle to create a cluster. And as I said, there will be Pulumi, Terraform, and other infrastructure as code samples at the end of this talk. For this sake, I'm using EKS Cattle. I create a cluster. I create an S3 bucket. And then I need to enable the pod identity. The create add-on is very important because it's not enabled by default. So, and by the way, each cloud provider has their own way of doing things. Like GKE and AKS have their own way, their own names, but the concepts are the same. The second thing that we do after we created the cluster and the S3 bucket is we create an IAM policy. So on the right-hand side, it's authorization. What am I allowed to do once I'm authenticated? And on the left-hand side, we see what identities, what principals are allowed to assume this role, right? So it says pods from EKS. And then this is the crux. If there is one thing that you should take from this talk, it's this concept of linking the two together. I'm linking a Kubernetes service account, in this case it's default, in the default namespace, with an IAM role from the cloud. And the way I like to think of it is if you take Kubernetes and you take AWS IAM and you leave them together in a room, you get the federated identity, and now you can access the cluster from your pods. No worries about that. So let's see how it looks like. We're going to spin up an AWS SDK pod. In this case, it's using the AWS SDK. And this is the magic. We're good on the times. This is the magic. So what you see on the top of the screen is accessing an S3 bucket. And note that I didn't have to provision even a single secret. I didn't have to change my code. All I did was changing the infrastructure around it. So I had to link the Kubernetes service account and the cloud IAM role. And there you go. The pod has the credentials to safely access the S3 bucket. How does it work under the hood? I don't like abstractions. I mean, I like abstractions, but I have a love-hate relationship because I want to know how it works under the hood. So there are two features for that. The first one comes from Kubernetes, the service account token volume projection. And the second one exchanges the Kubernetes token with the cloud token. So cool stuff. Yeah, it's a long list. We won't be able to go over it. One last thing I want to say. Workload identities are not a panacea. You still have to apply all the security principles that you are well familiar with, like multi-factor authentication, zero trust, least privilege. You need to monitor your environment, and you need to use secret scanning and vulnerability scanning and everything. Scan this QR code. You have a GitHub repo with examples so that you can apply to your existing infrastructure or any Kubernetes cluster that you want to apply to in the future. And thank you for the talk.